In 1960, astronomer Frank Drake pointed a radio telescope at two nearby stars. He was listening for a signal. This experiment, Project Ozma, established the method we would use for the next 6 decades, building massive dishes to catch incoming radio broadcasts. Since then, scientists have logged millions of observations across the sky. So far, nothing has been confirmed. The universe appears totally silent. That silence is a measurement of one specific type of signal. It assumes that an advanced civilization uses the same radio technology we developed in the mid-20th century. Humans have been broadcasting radio for a little over a century. Limiting our search to this narrow window of technology may be the reason we have yet to find what we're looking for. Instead of waiting for an intentional radio message, researchers are shifting their focus toward the physical evidence that technology leaves behind. These detectable traces of technology are known as technosignatures. A civilization thousands or millions of years ahead of us would likely manipulate its environment on a massive scale, leaving behind mechanical footprints rather than simple broadcast signals. These footprints could include artificial chemicals in a planet's atmosphere or enormous orbital structures that alter the light of a distant star. Researchers are now hunting for the physical consequences of technology, moving the search from a hope for communication to a study of cosmic engineering. To function on the scale of a galaxy, a highly advanced civilization would require immense amounts of energy captured from its stars. The laws of thermodynamics dictate that energy cannot simply disappear. Once used by a machine or a habitat, much of that energy must be emitted back into space as waste heat. This energy use creates a thermal fingerprint, a distinct infrared glow. A recent study examined 129 galaxies for this signature. The sweep returned 0 detections, but verified our ability to detect waste heat across interstellar distances. This negative result establishes a baseline for the search. It proves that we now have the technical capability to scan entire galaxies for the thermodynamic presence of intelligence. Beyond large-scale energy use, industrial activity fundamentally alters the chemical makeup of a planet's atmosphere. Earth provides the template. Our industrial activity produces synthetic molecules and pollutants that nature cannot generate on its own. A technological world light years away might be detectable through a similar chemical signature. When astronomers see something that deviates from natural patterns, it triggers an investigation. In 2015, Tabby's star showed extreme irregular dimming that some suggested could be an artificial megastructure. Further observations across different wavelengths showed the dimming was caused by ordinary space dust. The light was being blocked by a natural cloud, not a solid construct. This highlights a central rule of modern SETI. Strange data is the starting point, but it only indicates a physical anomaly worth investigating. Finding these anomalies requires a continuous stream of data from across the entire sky. The Vera C. Rubin Observatory is mapping how the universe changes in real time. Rather than looking at a single star, it records a 10-year record of cosmic motion and light. This generates millions of alerts every night for stars that dim or objects that move. Within this data, algorithms look for outliers that flag behaviors nature cannot easily explain. In this environment, the search for intelligence is a byproduct of scanning for statistical anomalies in big data. Before we can identify a signature as artificial, our systems must first find the events that violate our current understanding of the natural universe. The Fermi Paradox asks why the universe appears empty. This apparent silence may be a problem of detectability rather than a lack of life. Earth's radio leakage has only existed for a century, a blink of time compared to the age of the galaxy. Advanced civilizations may spend only a tiny fraction of their history producing detectable signals. If a civilization wanted to explore the stars, it might rely on autonomous, physical probes designed to endure for millions of years. These dormant objects could theoretically exist within our own solar system. They would remain long after a broadcast signal had faded away. This shifts the search from catching a fleeting transmission in time to locating an enduring artifact in space. The 66-year search has evolved from a single radio dish to a multi-layered investigation of the entire electromagnetic spectrum. The universe is under no obligation to use a language we understand or to announce its presence to us at all. Our new vocabulary includes waste heat, chemical fingerprints, and structural anomalies in starlight. The objective of SETI remains the same: to confirm the presence of intelligence beyond our world. We are no longer limited to waiting for a sound. By expanding our search to the physical traces of technology, we are learning to observe the universe as much as we listen to it.